On the physics of the sun and some solar eclipses and maybe even some science you can do during a solar eclipse. So please join me in welcoming Dr. Benjamin Boe.
Thank you for that lovely introduction. I research total solar eclipses. Here's a nice example of an eclipse from 2017. Some of you may have noticed this one potentially, or maybe you saw it as a partial. This one crossed the United States, and now we're about to have another one. So this was in 2017. We also have this most recent one. This was from 2023, just about a year ago in Australia. And you can see how different the corona looks each time. So 2017 versus 2023. And this is because you're seeing the magnetic field of the sun basically reaching out into space. And so we can study lots of properties about the corona. So what is a total solar eclipse? Well, this happens when the moon comes between the Earth and the sun, and it casts a shadow onto the Earth, like this diagram here, although this is horribly not at all to scale, not even close. This is what the Earth and the moon are like if you actually put them in their correct size and distances. You can see how far away the moon really actually is in space. Now, at this scale, the sun would be way over on the other side of the building somewhere, very far away. So this doesn't actually happen that often, that this alignment comes together in just the right way. Part of the reason too is that the moon's orbit is slightly tipped relative to the Earth's orbit. So there are some times a year, like on the left and the right there, that you don't get the alignment right. The moon passes below or above the sun, nothing happens. But if everything works out just right, that the moon is in the right place and the Earth is in the right part of its orbit, everything lines up and you get a total solar eclipse happening somewhere on the Earth. But it can happen anywhere on the Earth. And so our research team travels all over the planet to chase these. This is an example from 2019 in Chile and Argentina. This is near what we call solar minimum, when the sun is very quiet in its activity. And you can see a very characteristic, these rays coming out at the top and the bottom, and you see sort of this band on the equator. This is a classic magnetic field that you see from a very simple magnet. So like you've probably seen little bar magnet diagrams before. This is what it looks like. But if you go to other points in time, you start to get a little more active, a little more complexity. Now instead of just that one band, now you have sort of four parts that have these sort of closed field lines. And so this corresponds to what we call a quadrupolar magnetic field. So it's a little bit more complicated. And then during periods of solar maximum, it gets really chaotic. And it's very, lots of features, very small scale. So it looks very different over a period of time. And this is because of something that we call the solar cycle. So basically every decade or so, every 11 years, the sun has more or less activity. And usually we write this relative to something we call sunspots, which are these little spots that appear on the sun. And the number of them changes over the period of time. And so this is how that's changed over the last 100 or so years, 200 years. And so sunspots were actually originally discovered by Galileo, and he looked directly at the sun with a telescope, which you should not do without a filter. So he was definitely damaging his eyes to do this. But he not only saw the spots, but he saw that they would change over the period of time, so he saw the sun actually rotating. And so these were then recorded for many years after, and this is how we know about the sun going through these changes over time. Now there was one really interesting sunspot in 1859 that was being observed by this astronomer Carrington here. And what he noticed was all of a sudden there were these points that he labeled A, B, you can't really see the laser, but A, B, C, and D there, very suddenly got really, really bright. And no one had seen this before. And they went, what's going on? The sun had a flare. Oh, that's cool. What does that mean? Well, what ended up happening was a few days later, the world's telegraph system, because they didn't have the internet and cell phones back then, they used telegraphs, it got destroyed. And so what was actually happening was the sun had a massive eruption, and that impacted the Earth, and that caused the telegraph system to be destroyed. Today, this could be a much more serious event than it was back then. And so what Carrington had actually observed was that one of these spots on the sun had caused an eruption that then can actually impact the Earth. And so